Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. Thank you all for finding time and visiting today's webinar. My name is Nofara Aini. I'm from Faculty of Engineering and Built Environment, Masa University. Masa University located at Bandar Sarjana Putra, Tenjarum, Selangor. Come and visit us if you are nearby Bandar Sarjana Putra. Ladies and gentlemen, our interesting topic for today is geophysics, an alternative method for site investigation. And our speaker is Ms. Nurashida Ahmad Rashidi. If you have any questions during the presentation, just write them to the comments. Now, we can begin. Our today's speaker is Ms. Nurashida Ahmad Rashidi, obtained her master's degree in geotechnical engineering from University Technology Mara 2016. She is currently a lecturer in Department of Civil Engineering in the Faculty of Engineering and Built Environment at Masa University. She has worked as a civil engineer, has been involved in various design and construction projects covering both structure and infrastructure works. Without further ado, I would like to hand over this session to our speaker. With all respect, hand over to you, Ms. Nurashida.
Thank you, Ms. Farah. Okay, I would like to share my screen. So, okay, I guess, okay, screen. Okay, go. Loading, alamak internet. Okay, loading. Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good evening. My name is Nur Rashida binti Ahmad Rashidi. I'm a lecturer in Faculty of Engineering and Built Environment, Masa University. And today my webinar session is regarding geophysics, an alternative method for site investigation. This is actually like a simple sharing sessions like Geophysics 101 to those who just want to know what is geophysics and also what are the relations of geophysics method and also site investigations and some in engineering point of view. Okay, let's begin. Bismillahirrahmanirrahim. Okay, we start with the introduction. What is actually geophysics? Geophysics is a subject of natural science concerned with the physical processes and physical properties of the earth in the surrounding environment and use quantitative method for the analysis. Okay, the term of geophysics sometimes refers only to solid earth applications, earth shapes, gravitational and magnetic fields, structure and compositions, dynamic and surface expression for plate tectonics, and many more. Although geophysics was only recognized in the 19th century, but it is actually origins back into ancient time. Only in 20th century, geophysical method were developed for remote exploration of the solid earth and the oceans. Geophysics plays an essential role in development of plate tectonic theories. Okay, geophysics is applied to societal needs such as mineral resources, mitigations, and natural hazards, environmental protections. Well, in exploration geophysics, geophysical surveys data are used to analyze potential petroleum reservoirs, mineral deposits, groundwater, find archaeological relics, determine the thickness of glaciers and soils, and access sites for environmental remediations. Well, simply to say that geophysics is actually to study the earth, because the name is geo, using the physics concepts. Okay, how the method is by studying the wave that travels through the earth, and we study at the area again and then we achieve some data. By achieving the data, we are able to understand the area conditions. Okay. let's go for the types of geophysics. There are two types. There are few types of geophysics. Actually, there are many types of geophysics there is in the industry, but this is actually the common use of geophysics that you use. Okay, they have seismic method, resistivity method, ground penetration radar, electromagnetic method, and many more. Okay, for seismic method, it's actually to identify the subsurface profiling. Okay, because you want to know the underground conditions. What is underground conditions? Okay, for resistivity method, usually using the electrical method to identify like liquid in the soils, and also liquid in the soil as well as subsurface profiling. For ground penetration radar, usually commonly used to identify pipelines in soil. Okay, so this actually varies in different of method of conduct, but actually it come up with the same result, which is identifying the subsurface profiling. Okay, so I'm gonna go deeply to seismic wave. Okay, since geophysics has many types, but my experience is more on seismic wave. So let's see what is actually seismic wave. Seismic wave is actually one of the geophysical method. Seismic wave are wave of energy that travels through earth layers and are result of earthquakes, volcanic eruptions, magma movement, large landslide, large man-made explosion that gives out low frequency acoustic energy. So these actually are the wave that travel and propagates through the earth that eventually occurs an earthquake. So larger seismic wave occurs, larger earthquake might happen. So this is actually a very dangerous wave. Is it dangerous? It can be, okay? And there are a few types of seismic wave. We have two types, actually two main types. We have body wave and we also have surface wave. Body wave also divided into two types, which is P wave, also known as primary wave, and also S wave, which also named as secondary wave. Meanwhile, surface wave consists of Rayleigh and Love wave. What are the difference between those waves? The difference between those waves is actually the propagations. Okay, there are different propagations means movement. Okay, because wave travels, okay, and then it moves. The difference between all this wave is actually the movement. For example, P wave, as you can see the movement here. Okay, the movement here, P wave move in the particle motion like that, has a longitudinal particle motion linked with the propagational direction. Okay, particle motion consists of alternating compression, and usually P wave of seismic wave, also called a primary wave, can travel through solid, liquid, and gas. So if it travels underground, so it can just go to whatever solid, liquid, and gas. Okay, difference with the next one, which is S wave. S wave, you see the movement? You see the difference of the movement? Just now it is propagation straight line. But S wave usually is also known as secondary or shear wave because it has a shearing effects. Okay? You see, can wave is like wavy like that. So shearing usually pass through solid. Okay, because we cannot have shear in liquid and also gases. So mostly shear wave travels to shearing solid. Okay, so this wave is particle motion and is going up and down. For surface wave, which is consists of Rayleigh and also Love wave, you see the movement, you can see the difference of the movement. So it's like Love wave, the particle motion is moving in the side by side direction, but still have the waving technique. And also Rayleigh wave, it move in like a circular movement. Okay, so all of this wave is actually the one that travels through the earth that eventually produce earthquake. So this wave seems so big, and can it be related to site investigation? Let's see. Because of course, yes, it can. Because this wave technique, okay, when it's larger scale, of course, it happen in earthquakes. But even smaller scale, you can use to detect many things. For example, geophysics in site investigation. Before we go further for geophysics relation to site investigation, let's see what is site investigation. Okay, site investigation is the process of collecting information, assessment of the data, and reporting potential hazard beneath a site which are unknown. Okay, the objective of site investigation is to gather information needed to carry out the risk assessment in order to be in a position to assess the presence and significance on the land. Okay, as a civil engineer, for myself, I'm a civil engineer. Site investigation is the most important thing prior to construction. Okay, before you start any construction, you need to identify your site first, because most construction done on the ground. Okay, most of the construction are done on the ground surface. So basically, we need to know what we are dealing with. Okay, so we need to identify what is the ground condition, underground condition, the soil condition, what is the strength of the soil, uh, the everything, the parameters of the soil we need to understand, because we need to build a very strong structure above. If we do not know what is the conditions of our ground, it might affect the stability and the strength of our structure. So site investigation actually involve many stages. One of it is actually soil investigation, where you dig the soil and you run some testing and you get some parameters, and that parameters is useful for design process. Those parameters shows how strong the soil is. So before this, the site investigation was done using a conventional method. Okay, what is conventional method? Okay, usually this is what engineers do inside. Okay, so this is the layers of soil. Okay, another thing is why we need to do site investigation, because underground, okay, bear in mind, underground is full of uncertainties. We do not know what we have under the ground. We might say this one have sand, this one have silt, this one have clay, but it can be mixture of both. It can be anomalies. It can have anomalies. It can be uncertainties. Okay, because that's why we need to investigate what is underground, so that we are able to work with it more efficiently. So before this, a conventional method, what they do is they you have a you for just imagine you have a very large site area that you want to build a construction above. Okay, so you, based on the engineering practice, what we do is we pick the most critical design, critical load design. So we critical point lah, okay, critical points. So we dig the area, okay. For example, like my side here, okay, I choose 3 points. Okay, 3 points. Okay, I dig that area. I excavate using heavy machines. I excavate. I do messy works. Okay, I took out the soil and then I run some tests, and then I got the test, and then it's useful for the design concept. Okay, so this is actually what we do in conventional method. But like I mentioned before, okay, underground is full of uncertainties. You do not know what is it underground. You cannot. It is actually quite dangerous to assume this part is the same with this part. So, for example, what if there is anomalies under the ground? For example, boulders, okay, or maybe cavities, or maybe groundwater. So usually conventional method, although it's very good, but it just give you a discrete data. Discrete data means the data on the area only, so it does not give you an overall area. So it's quite dangerous like that, but usually it's okay lah. Okay, but now we came up with an alternative or more advanced method to actually identify the whole area using geophysical method. Okay, how does it conduct? Okay, so this is, can you see the purple one? This is actually a pile. Okay, usually we do the testing of bore logging for the point that we choose, which is the maximum point. But the pile we need to install at all area. So what if that pile that we install have gone into the boulders? So it might affect the stability of the building in future. So it's quite dangerous. So this came how geophysics can be an alternative solutions for alternative method for site investigations. Okay, geophysical method in site investigation is conducted by having the machines. It's not very heavy. It's a very light machines, and also some detector, signal detector called geophones, be installed along the site. Okay, with some certain span. Okay, and then like the guy is doing here. Okay, so and then we need to produce some because we need to make the wave to produce. So we knock, okay, and then we knock, so and then the wave produce, and then when the wave travel through the earth underground, when it detects some anomalies, it will return back the signal up to the signal receiver, and we by that we can able to achieve the data, and we can able to identify the subsurface profiling better. Like I mentioned before, seismic P wave can travel to solid, liquid, and gas. So the wave can travel through anything. So you can get the results better. So and then okay, this is actually the underground conditions. Okay, we have the layers of soils, and then we have the anomalies. For example, we have the boulders, cavities, and underground water. So if we install the seismic method, seismic testing of geophysics, okay, where the signal, and then this is the wave producer, means we have to point somewhere, and then when the wave travel back, it covers the whole area, so we are able to identify the whole area. So this provide an overall data for the area, so that then the result will be much more clear in the larger span. Okay, so and then of course, and this seismic also can be installed in some span. For based on my experience, we can install around 120-meter length. So the longer you install the seismical machines and equipment, the deeper the signal will go, but it will up to 30-meter depth lah. Okay, so and then you will cover the area, and then you can understand the anomalies. You will get some picture of what is actually the overall area of the subsurface profiling. Okay. Okay, how geophysics can be an alternative method for site investigation? Because conventional method that I mentioned before, is actually consuming time, consuming money, and then because it is very messy, because it is destructive. Okay, destructive means you have to destroy the thing, you have to dig, you have to be messy. So it is very destructive. Okay, and then it requires a lot of time, of course, a lot of manpower, skill, non-skill, and then some more, it only provide discrete data. So the advantages of geophysical method is able to cater that problem, which is intrusive and more clean. Okay, you don't have to dig, you just have to install the machines. So it's not very heavy, the machines also. And then of course it save a lot of time, manpower, and money, definitely. And it provide an overall data for the larger area span. So it's a good method, advanced method to actually we can be investigation. And we go to the data interpretation. After we run the tests on the what do you call, on the site. Okay, so of course we need to go home and analyze everything, analyze all the data. So this is what eventually the result that we get. Okay, seismic tests usually provide the data of velocity value. So velocity, with having the velocity value, we can actually compare with the previous study. Okay, this velocity says that what type of soil. Okay, so we can do a lot of comparison, and also we can also compare with the testing that we made on lab. So it can actually support more the data. So this is actually the data interpretation after you get, so you can characterize by layers, so you can get the distance, so you can know, oh, this one got water, oh, this one got walls. It's actually when you analyze properly, you're able to get a perfect data. So it's good because you can get the overall subsurface profiling. And then sustainability factors and this. And of course, now everything is going towards sustainability. Okay, sustainability consists of three, which is economic, social, and environment. So this method also, for my experience, for my opinion, it also have a sustainability factor. Number one, because it is intrusive. It does not it is not extrusive, so it can save a lot of things in the environment lah. And then economically, of course, it's saving costs, saving manpower, saving energy. So, and then it's easier to conduct. So it's have a lot of sustainability factor with it, and also more advanced. Which can also engineers can now apply this as an alternative method for site investigation. And the last one is conclusion. Okay, now we already reached the conclusion. Geophysics is an alternative and innovative method for site investigation. Okay, so it's not that a geophysics method is a method that we want to replace conventional biology method totally. No, but for now we can say that it is an alternative method that we can support the conventional biology. Maybe we can done both. Okay, for example, like biology we can take, and then to cater the data, that the discrete data that boreholes cannot get, so we can use the we can use the seismic method to support, means to support the data, so make the data more reliable, more strong, and more effective, so that we can use the data for our construction industry much better lah. Okay, and then of course this is a very new innovations. Okay, and innovations help save many factors, and it's very good compared to manual work. So biology is a manual work, you have to dig and whatsoever. This one is very okay lah, environmental friendly. But however, much more research in geophysical method, seismic, or maybe ground penetration data, or all the method of geophysical method needs to be done more in order to prove that the data is more reliable and eventually can be a good alternative method to be applied to all site investigation. So that's all for today. So I guess that I hope that my sharing session, although it's a brief sharing session today, I hope that it will be benefited all of you, since and also this is actually a very new information regarding geophysics. Not many people know about geophysics. Most people like to do conventional methods. So by having this brief sharing session, so I hope that gives you idea, oh, you can actually apply this in construction industry and make the result and make our work much more better, and the result much more better in industry. So maybe we can apply it for a better future. And with this, I end my speech. I guess thank you for today, and thank you for your time, and we'll see you in the next session, inshallah. Assalamualaikum. I'm Nur Rashida.
Thank you very much, Ms. Nur Rashida, for the interesting webinar. Geophysics as an alternative method for site investigation is really needed in align with your sustainability and also IR 4.0 like demanding nowadays. Okay, so we really appreciated the knowledge and information that you share with us today. Thank you, viewer, for spending your time into this webinar. We hope to see you guys again next time for all our Masa University webinar that will be covered more interesting topics. Don't forget to save your date for our webinar session via Masa University Facebook page, and don't forget to visit our Faculty of Engineering Masa University website. Okay, until then, I'm Nofara Ain. Take care, be safe, and be more. Thank you. Bye.